Good evening, everybody. Firstly, I want to thank you all for coming tonight. We're delighted to welcome you all. We have students, friends, staff and family, and particularly our friends Grace and Chris from Zambia. We welcome you. And we welcome Dan's family, Sally, Philip and Jacob. And I know Philip has just sneaked in, haven't you, all the way from London to manage to come here as Dad this evening. I'm Kate Reynolds, and as Dean of the School of Education, I'm really delighted we're here tonight, recognising the importance of education research as a key part of Validity University. Research within the school is wide-ranging and touches on topics which have practical application across education. Our topics include areas such as building capacity in higher education, the use of pupil premium in schools, and work around attachment awareness, just to mention a few. Much of our research is done in partnership with others, some of whom will be represented here tonight. Local councils, schools, teaching school alliances and trusts all play a key role in helping us shape relevant and robust research. Later this year, many people will know, we'll be launching our major piece of research into the different routes to teacher education. Who becomes a teacher, how and what difference the training and education of teachers make, and Dan will be a key part of that. Tonight's lecture, I understand, is the first from the School of Education and focuses on the key educational topic of the question of educational assessment and some of the theoretical and empirical questions it raises. The lecture will be presented by Professor Dan Davies, an eminent researcher in the school with a particular interest in science and technology education. Dan's own research reflects the school's emphasis around marrying research with practical application in the classroom. So a little bit about Dan. Many of Dan's colleagues will be surprised to know that Dan is actually a very embodiment of the Govian approach to teacher education. Because Dan studied for a physics degree at UCL, and having graduated, he then became a primary school teacher. I have to say to you, Dan, you can get bursaries for that. Well worth looking at, and I hear Philip might be nudging down the same route as well. Dan then spent many years teaching a diverse range of celebrities in the challenging context of South London. In particular, at St James's Church of England Primary School, he was the teacher to one Jade Goody, and how well she did. Thank you, Dan. Dan's masters at Goldsmiths furthered his approach of bringing the real life of education into academia, with research focusing on opera created by inner-city pupils and supported by the Royal Opera House. Dan received his PhD from Goldsmiths and came to join us in Validity University in 1998. His interest in science and technology continues to be reflected in his teaching and research, having published a significant number of different papers, books and classroom material relevant to science and technology in schools. Having reviewed Dan's career for this presentation, this introduction to this lecture tonight, I could find absolutely nothing about a cat. So I'm particularly looking forward to Dan's professorial lecture, Schrödinger's Cat and the Educational Assessment Paradox of Measurement or Judgement. Ladies and gents, Professor Dan Davies.
Thank you very much, Kate, and can I add my welcome as well. Thank you all so much for coming. When I became a professor back in 2005, Validity University didn't have inaugural lectures for professors. So I'm treating this as mine, albeit 9 years late. The enigmatic title to this lecture, which I must confess I concocted to make a talk about assessment sound a bit less boring, brings together my background as a physics student with my current role in the Centre for Research in Early Scientific Learning, CRESL. A number of my CRESL colleagues here this evening. We're currently in the first year of a 3-year project, TAPS, or Teacher Assessment in Primary Science, funded by the Primary Science Teaching Trust, which we hope will provide some answers for teachers grappling with this thorny and unfortunately deeply politicised issue. I will come back to the cat, I promise. But I want to start with my favourite piece of educational research. And not just because John Hattie here is a fellow New Zealander, working at the University of Auckland, where I was lucky enough to spend a 3-month sabbatical a few years ago. He undertook the largest meta-analysis of educational research studies ever attempted in order to try and answer this question: what single thing can schools and teachers do to make the most difference to their pupils' learning? His methodology has not been without its critics, but he did manage to arrive at what remarkably little educational research manages to achieve: a clear answer. And here it is, in rank order. The things that make the most difference to pupil achievement. And right at the top is teacher feedback on learning, what we might call formative assessment, or assessment for learning. It's actually quite salutary to take a look down the list and see some of the things we set so much store by in education, which appear to have relatively little impact. The number in the second column, the effect size, refers to the extent to which each influence changes the distribution of pupil achievement. So here we've got the standard bell curve, or the normal or Gaussian distribution of pupil achievement. And the difference between these two, well, the several green lines here, is the standard deviation. The standard deviation is a measure of the width of the curve. It's actually defined as the square root of the mean distance of each point from the centre line. The effect size is defined as the difference between the midpoints of the original and the new curve after the effect has taken place, divided by the standard deviation. So, the 1.13 effect size for feedback is pretty massive. It's over a whole standard deviation, and it's definitely statistically significant. Clearly, not any kind of feedback will do here. It can be written or verbal, but Butler found, significantly, that if a numerical mark is given with the feedback, students ignore the feedback and focus on the number. Harlan found that general praise might help students feel good about themselves, but was unlikely to help them to improve. It takes real skill on the part of the teacher to suggest improvement steps that are relevant to the student. So this, if you like, is what we might see as the good side of assessment on the left, that focuses on helping the student. But what about formative assessment's evil cousin, that's used to label children, restrict educational opportunity and rank schools in league tables? Yes, I'm talking about summative assessment. For many teachers, it's a necessary evil. But we seem to be caught in a dualism here, where we tend to separate the two forms from one another. Something my colleague Sarah Earle, member of Cressel, found when she analysed school submissions to the Primary Science Quality Mark database as part of our TAPS project. The schools tended to describe their strategies for formative assessment in science completely separately from their systems for tracking pupil progress, forgetting that the same processes of gathering evidence and making judgments upon it lies at the heart of both purposes of assessment, and that actually one should feed the other, breaking down the formative-summative divide. This principle lies at the heart of the model that we're proposing in the TAPS project. One feature of summative assessment that tends to make teachers view it negatively is its frequent high stakes. This stuff really matters to the futures of students, teachers, or schools. But wait a minute. In what other contexts do you hear the phrase high stakes? That's right, gambling. We're introducing the idea of randomness here, or chance. which is a bit awkward if these assessments matter so much. Last year, I had the privilege of visiting Nepal, where the 16-year-olds sit a national examination called the School Leaving Certificate, or SLC for short, similar in some ways to our GCSEs. Such is the high-stakes nature of this assessment that they take at the end of secondary school, that it not only affects students' access to the upper levels of secondary school, to higher education and to careers, but it even determines whether they're allowed to learn to drive. In Nepal, it's known as the Iron Gate. There are several issues with the SLC, such as its discrimination against students from the kind of remote rural areas where these students live, such as here, Nangi in the Annapurna foothills. Educational research is tough. So. The exam also tends to prioritise memorisation and recall over problem solving, which was the focus of criticism of the staff at Himachal High School. However, my subsequent interviews with government officials revealed some of the vested interests within the education system in Nepal that oppose reform of this 80-year-old examination system. So that example from Nepal is characteristic, I would say, of a strong international drive towards high-stakes maths testing in education, which is seen as a rigorous, objective way of measuring pupil achievement, allowing the effectiveness of national education systems to be compared with one another. The simple equation here appears to be assessment equals measurement, which rests on the positivist assumption that individual attainment is an objective reality which can be reliably reduced to a series of numbers or grades. It borrows its epistemology, its theory of knowledge, from the physical sciences, where the possibility of accurate measurement is taken for granted. Can you see where I'm going here? Or is it? My background is in physics, where, in the early 20th century, quantum mechanics cast doubt on the whole notion of accurate measurement. This is Werner Heisenberg. I'm sure you've all heard of his uncertainty principle. Essentially, if you're trying to fix the position of a tiny particle here, you have to bombard it with a photon of light in order to be able to see it, which in turn knocks it out of position. You can never know both the position and the momentum of a small particle simultaneously. The product of their uncertainty is always greater than a certain constant. Such is this indeterminacy that every particle can be thought of as a wave packet. And Heisenberg's uncertainty principle has entered modern popular culture. So here's a probability wave representing where a particle might be at any one point in time. Notice, bell curve. Remind you of anything? Some physicists, such as Erwin Schrödinger, had problems with indeterminacy. So he posited a thought experiment to demonstrate its inherent absurdity at macro levels. So here we are at last. So, Schrödinger's cat is in a box which also contains one atom of a radioactive source in this bottle. a Geiger counter which registers when that radioactive source emits a particle, which is in turn connected to a vial of poison gas. There is a probability wave affecting whether the atom decays or not, emitting a particle that triggers the Geiger counter and kills the cat. Because of indeterminacy, the atom exists in both states simultaneously, both decayed and undecayed, with the wave function only collapsing into a definite outcome when we open the box and look inside. So the cat is both dead and alive until we observe it. Preposterous. And what has this got to do with educational assessment? Well, we could see the box as a student's potential. Now, let's not mix our metaphors by thinking outside the box here. But if the box is a student's potential, we only fix that potential at a point in time when we make an assessment of them. Until then, there is possibility, and we're constraining that possibility or affecting that possibility through our assessment. I think it's no coincidence that Paul Black and Dylan William called their seminal text on assessment for learning Beyond the Black Box. This uncertainty is to an extent already represented in assessment theory, where it manifests itself as testing error. For example, in classical test theory, the error, E, represents the gap between a student's true score, we might say their potential, T, and the observed score, what they actually got. Both item response theory and rash measurement theory are predicated on probability, encapsulated within the following statement from Rash. We can never know with certainty how a pupil will react to a problem, but we may say whether he or she has a good or poor chance of solving it. Sounds a bit like indeterminacy. How does this uncertainty or error arise in assessment? Well, here we encounter some key criteria for effective assessment: validity, reliability, impact, and manageability. So, there might be a problem with the assessment instrument itself, its validity. Or maybe it's the effect it has on the students when they take it, its impact. Perhaps the criteria for success might be interpreted differently by different assessors. Reliability. Or it's so cumbersome to implement that errors creep in. It's manageability. Just as we can never fix both the position and momentum of a tiny particle, we can never have an assessment which is both perfectly valid and entirely reliable. Take a multiple choice test. If there's really only one unambiguous answer to each question, then it can be marked by a machine. Its reliability is very high. But if we were wanting to assess something a bit more complex, say scientific reasoning, creativity, the ability to carry out a scientific inquiry, we've sacrificed validity for that reliability. Conversely, teacher observations of children doing science might have much greater validity. But unless they're very carefully recorded, it's possible someone else might reach a different conclusion from the evidence, so their reliability is suffering. What we need is assessment which is valid enough and reliable enough for the purposes we intend to use it for. Let's return for a moment to the idea of assessment as measurement and consider the example of the national curriculum in England, now in its 26th year. Its assessment structure is highly quantitative. But where did all these numbers come from? There's a picture to warm the heart of anyone teaching in the late 80s, as I was. Who's the chap on the left? Kenneth Baker, the Secretary of State for Education and architect of the national curriculum, which was famously opposed by Margaret Thatcher. She said, a national curriculum is incompatible with a free market school system. She lost that debate, and in fact her ideas have only been implemented in the last few years by the government we have at present, who have introduced free schools and academies which don't have to follow the national curriculum. Anyway, in 1988, Kenneth Baker commissioned the TGAT report, which set up the system of levels that we all know and love. However, the diagram in the original report is somewhat different to how it's ended up. You'll notice, for a start off, it only starts at age 7, and originally went all the way up to 16, to GCSE level. That was all pretty soon abandoned, the link with GCSE grades. There's an assumption here of linear progress, with the average child gaining one level every 2 years. Notice that these are expected levels, i.e. average. Level 2 at age 7, level 4 at age 11. But it's also assumed there will be a wide spread of attainment, both above and below these lines. So a spread of up to 3 levels at age 11, from 2.5 to roughly 5.5. This corresponds to a normal distribution a bit like this, with a standard deviation of about 1 level either way. However, in 1997, the new Labour government turned these norms into baselines, setting the target that 85% rather than 50%, as would be implied by this model, of 11-year-olds should be at level 4 or above. This corresponds either to an attainment shift of over 1 standard deviation, possibly achievable through good feedback, as we saw earlier, but resulting in a significant proportion of children at levels 6, 7 and 8 at age 11, which is going to be a headache for secondary teachers. Or a narrowing of the bell curve and a shift that seems highly improbable. The UK government, however, doesn't have a monopoly on statistical illiteracy. Because of the difficulty of demonstrating progress over such a wide-spaced scale, the teaching profession itself has subdivided each of these levels into A, B and C. This is not official national curriculum policy. But nevertheless, the Department for Education have taken to it with gusto, further subdividing these sub-levels into APS, average point score. Each point is 1/6 of an original TGAT level. Apparently, to calculate the APS from a level, you multiply by 6 and add 3, for some reason. This division of those original TGAT levels, 1 per 2 years, into 6, brings us the rather neat expectation of 1 point progress, i.e. 1/6 of a level progress each term. But I can't help feeling this is a bit of an over-interpolation of the original model. The proliferation of sub-levels in national curriculum assessment provides a good example of what I shall term the seductive myth of numbers. Head teachers and Ofsted inspectors love this stuff because it looks like hard scientific data you can play around with. It has proliferated a whole industry of numerical assessment and tracking systems that provide amazing spreadsheets and predict pupil progress from term to term. How do they do this? Simply by adding the TGAT-derived average progression rate onto each child's assessed sub-level. So a level 3B becomes a 3A target for 2 terms' time. This is what parents get told in reports and parents' evenings. Okay, parents, how many of you have been told targets like that? Oh, what does it mean? It's not magic, it's just simple arithmetic, based on, I would argue, a flawed linear model of progression. Parents can't make any sense of it, and that original 3B is still based on teacher judgement, or extrapolation from previous tests, so it's no more scientific than a tick sheet. Target setting, I would argue, also destroys the whole purpose of assessment, since, according to Goodhart's law, derived from banking, especially if teacher pay is based on it. Can the accuracy of our assessment sustain such a fine-grained model? Well, a couple of findings here. He et al. Found that national curriculum testing was at best 90% accurate, and that's for the old big TGAT levels. So how accurate is it for levels that are 1/6 as wide as those levels? Leckie and Goldstein found that a lot of the data that was being used to compare schools was not sufficiently robust to actually make those fine-grained comparisons that were necessary. So, perhaps our elaborately constructed mountain of data just ends up looking like a castle built on sand. This then, I would argue, is the educational assessment paradox. The more accurate we try to make it, the less valid it is. However, I have good news. Help is at hand. I bet you never thought you'd see those words and that image together. There's not much I'd like to commend Michael Gove for, but he has abolished levels in the 2014 national curriculum, replacing them with age-related statements of attainment, which, okay, is not a great replacement, but I think it could be an improvement. This, however, creates a headache for schools who've been operating with levels for the last 26 years. It's scary, and the schools that we're working with on the TAPS project are as scared as any of them. So how do we show progress in a post-levels world? Well, here's one answer. This is Alison Peacock, and she is the head teacher of Roxham School in Potters Bar, state primary school. This school, highly commended by Ofsted, and she says, we have not talked to children and parents about levels for the last 10 years. Families are very well informed about their children's achievements and progress, as this is evidenced in the manner in which each child can talk about his or her learning and the next steps for improvement. So it's a qualitative system rather than a quantitative system. If we must track pupil progress against the new age-related statements, we could use something like a traffic light system at the beginning and end of the year, where red is not yet, yellow is perhaps getting there, and green is secure, or even exceeding that statement. But hang on a minute. Isn't this just the same as sub-levels A, B and C of the age-related levels? I can foresee the whole tottering numerical castle being reconstructed. Is there an alternative? Well, from 2007 to 11, I was involved in an e-portfolio assessment project called eScape, which looked at new ways of assessing primary and secondary students carrying out scientific inquiries, using netbooks on their tables so they could record as they went along. eScape stands for E-Solutions for Creative Assessment in Portfolio Environments, and it's actually in use in a number of countries, such as Sweden, Singapore and Brunei. It affords what we might call a multimodal response from pupils, depending on their preferred modes of communication. So, children might prefer to write or type. They might prefer to draw diagrams, pictures. They might like to take photographs of their investigations as they go along. They might want to record their voices to explain their understanding of scientific phenomena. Or they might want to take videos of each other and provide voiceovers to record the process of an investigation. And because all of those pupil netbooks are connected wirelessly to the teacher's laptop, all that work is saved and transferred so he or she can see the e-portfolios as they emerge. But the really radical thing about this approach is how those e-portfolios are then assessed through a process called adaptive comparative pairs, which is based on the comparative judgment research of psychologist Leon Thurston. Now, his claim is that humans are much better at making relative judgments between two things than absolute judgments against a scale. To illustrate this, I'll use an example from Matt Wingfield of Tag Assessment, with whom we worked on eScape. So, I'd like you to rate the temperature in this room on a 10-point scale, where 1 is the coldest temperature you've ever experienced, and 10 is the hottest. Okay, hope you've done that. So, as I read out the numbers, just put your hand up if you have chosen that number. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we had a spread between 4 and 7. Okay, it actually made quite a nice normal distribution, a nice bell curve there. Okay, now I'd like you to compare the temperature in this room to the temperature out there. Okay, I'm not going to invite you to all go out there and find out, but try and remember what it was like out there before you came into this room. Okay. So, those of you who think it's warmer in this room than out there. Okay, those of you who think it's warmer out there than in here. We have a reliable assessment strategy. Compares comparison. So, adaptive comparative pairs, or ACP, uses an online engine which shows each judge, in this case the teacher, a pair of portfolios and asks them to choose the better of the two. Then presents another pair and gradually adapts the process to compare portfolios that are closer and closer in quality. In one case, we had 156 pupil portfolios, all on the same task, from 8 schools, being judged online simultaneously by 8 teachers. Now, the process assigns each portfolio a parameter value, which is the likelihood of it winning a pairs comparison judgment. Portfolios in the middle of this plot have a parameter value around 0, indicating that they have won, or would win, comparisons with around half of the other portfolios. Portfolios at the far left, over here, have a parameter value approaching -10, indicating they lose most of their comparisons, whilst those at the far right have a +10 parameter value, as they tend to win all their comparisons. The slightly longer error bars that you can see in some portfolios indicate a degree of disagreement between the judges as to their position in the rank order. However, overall, this rank order has a reliability coefficient of around 0.9, which is about the same as National Curriculum Stats tests. So ACP achieves its reliability through moderation between teachers. Let's apply that to higher education. And if you are a student at this point, just cover your ears. Okay, so let's pretend that this is a typical discussion about a piece of student work. How are these tutors arriving at their marks? Is it through aggregating the essay's performance against each of the assessment criteria? I would suggest not. What I would suggest is happening here is they are comparing the work using their own internal pairs comparison engines. The guy on the left thinks it's a bit better than the one he gave a 53 to, and not quite as good as the one he awarded a 55. Whereas the tutor on the right is making similar comparisons using a slightly differently calibrated pairs engine. So the purpose of moderation here is to bring their judgments into line with each other through discussion, to recalibrate those pairs engines. And I think as educationists, we are very fond of talking about criteria and referenced assessment. That's how we assess at GCSE level, in school and university. But I think scratch any criterion and there's a norm hiding underneath it. So, returning to our original assumption, I would suggest that assessment isn't really about measurement. It's got more to do with human judgment. More of an art than a science, perhaps, but no less valid for that. So, with Schrödinger's cat in mind, what might a quantum theory of assessment look like? Well, it might include the following assumptions or tenets. It would recognise that there is an inherent indeterminacy in educational attainment, the box, the potential of each student. It would recognise that assessment involves judgment and that inevitably involves error. It would carefully select a balance between validity and reliability, which is appropriate to the purpose of the assessment. How valid does it need to be? How reliable does it need to be for the purposes you're going to use it for? And finally, it would recognise that as when we observe an electron, we knock it out of position, the act of making an assessment affects what is being assessed. There is always an impact to assessment, and the role of feedback, to return to John Hattie, is to ensure that that impact benefits the learner. So you all wondered what this was, didn't you? What is in this box? Well, it's not a cat. Okay? I couldn't get either of our cats to stay still long enough. I did try to stay in a box for 40 minutes. Neither is it insulated cups. Though actually, isn't this a wonderful example of indeterminacy? Hot or cold insulated cups. We don't know whether they're hot or cold until we look inside the box to find out. They are truly Schrödinger's cups. There's a probability wave in there. They are both hot and cold until we have a look inside to find out which they are. No, I've got a child in the box. And I know that the child is either a 2A or a 3C, but I'm not sure which. Could be either. Could be both simultaneously. And the only way I'm going to be able to find out what that child's level is to look in the box. So, let's do it. Oh. Oh no. Oh dear, dear, dear.